Hi everybody, today we're going to talk about factoring polynomials. Factoring is undoing the multiplication in an expression. We look for common numbers or variables that are common to each term in the expression and rewrite the expression with the common factor divided out of each term. We're going to start by factoring out the GCF. The GCF means we are trying to factor out the greatest common factor that divides all terms in the expression. So let's do some easy examples to get us started. When I look at 4x plus 8, I notice that both 4 and 8 are divisible by 4, so I'm going to factor out that 4. If I divide 4x by 4, it leaves me with x. If I divide 8 by 4, it leaves me with 2. Our second one says 7x minus 21, and again, I look for what's common to both, which would be the number 7. When I divide 7x by 7, I just get x, and when I divide negative 21 by 7, it leaves me with negative 3. This next example is a little bit bigger, but I'm still just looking to take out the GCF. So I have 5x cubed plus 15x squared plus 50x. So this time I notice two things. I notice the 5, 15, and 50 are all divisible by 5, and I notice x cubed, x squared, and x all have an x in common. So I am going to take out 5x from each expression. So I want you to think of kind of looking at the number part and the variable part separately. So 5 goes into 5, that part is gone. X cubed divided by x leaves me with x squared. You can think about subtracting the exponent. So if I do 3 minus 1, I get 2. Now I have plus. 15 divided by 5 is 3. I took out an x, so 2 minus 1 leaves me with 1. Then 50 divided by 5 is 10. And then that x cancels out, so I don't have anything left with the 10. You don't have to write the 1s as the exponent, so we can write 5x times x squared plus 3x plus 10. The next one says ax to the 5th plus ax cubed plus ax. So I have a common to all three terms, and I have powers of x. I'm going to take out ax. The a is going to come away from all of them, so I really just need to look at the x here, and again, I can think subtraction. So 5 minus 1 leaves me x to the 4th. 3 minus 1 leaves me x squared, and then the x divided by x is just a 1, so I'm going to stop. Hopefully, as you were looking at that, it reminded you of something called factoring trinomials, and there are 4 basic types of trinomials for us to look at. I have x squared plus bx plus c, I have x squared minus bx plus c, x squared minus bx minus c, and x squared plus bx minus c. So hopefully you see what changes in each of these is the sign in front of the b and the sign in front of the c. So let's look at them one at a time. Let's start with x squared plus bx plus c. The plus in front of the c tells me that both factors are going to have the same sign. So as an example, if I have x squared plus 15x plus 44, I'm looking for factors of 44 that are going to add up to 15. Now, if you ever get stuck, you can just start writing them all down. You could say, well, I know I have 1 and 44, and I have 2 and 22, and I have 4 and 11, and then you're adding them up. 1 plus 44 is 45. 2 plus 22 is 24. 4 plus 11 is 15, and that is what we're looking for. So as I'm separating this out, I'm going to write x plus 4 and x plus 11. The order doesn't matter. You could write x plus 11 before the x plus 4, and you would get the same thing. So our second type is x squared minus bx plus c. And again, we see this plus sign in front of the c, and the signs are going to be the same. They're both negative. So really pay attention to that. When c is positive, you look at the coefficient of b. If it's negative, they're both negative. When it is positive, then the factors are both positive. So this time we're going to try x squared minus 8x plus 15. Again, if you want to write down the factors 1 and 15, 3 and 5, that works. This time they're both negative. So negative 1, negative 15, that gives me negative 16. Negative 3 plus negative 5 is negative 8, which is what we want. So I'm going to write x minus 3 times x minus 5. This time, the coefficient of c is negative, and what happens there is that you really have to look at the factors. The bigger one will have the same sign as b. So let's look at this, x squared minus 9x minus 36. I start looking at factors of 36, 1 and 36, 2 and 18, 3 and 12, and I can see 3 and 12 have a difference of 9, and that's what I start thinking is when c is negative, I'm subtracting my two numbers. The bigger number, which is 12, will get the negative sign. So I'm going to have x minus 12, and I'll have x plus 3. So when I multiply negative 12 by 3, I get negative 36, but when I add negative 12 to 3, I get negative 9. Very similar if I switch over to negative c with a positive b, the bigger number will get the positive sign. So with negative 14, I think factors are 1 and 14. I could have 2 and 7. Those are my choices, so I stop at the 2 and 7. 5 is positive, so I'm going to leave the 7, the bigger number, positive, and the 2 will be negative. So I have x minus 2, x plus 7. Let's try one more like that. Here I have negative 72. So you start thinking through your factors of 72, and hopefully you come up with 8 and 9. 9 is bigger, so I write a positive. X is smaller, I write a negative. Sometimes as you're doing trinomials, you're going to come across one where the leading coefficient is not a 1. So let's start by just seeing if we can factor out that leading coefficient. So I have a 3, a 9, and a 6, and that says yes, I can take the 3 out. That gives me x squared plus 3x plus 2. I'm going to keep that 3, and I'm going to think about factors of 2 that add up to 3. Well, luckily, 2 only has one set of factors that are 2 and 1. 2 plus 1 is equal to 3. And it makes it much easier because I took that 3 out and I didn't have to worry about as I factored. So let's try that a few more times. I have 5x squared plus 5x minus 30. I'm going to take out a 5. That leaves me with x squared plus x minus 6. I am looking for factors of 6 that have a difference of 1. So I have x and x. I'm going to write 3 and 2. 3 is bigger, it's positive. 2 is smaller, it's negative. The next one says 7x cubed plus 14x squared plus 7x. Now they all have a 7, so let's take the 7 out, but they also are all divisible by x. So I'm going to end up with x squared plus 2x plus 1. Now you're looking at 1 and you're thinking, what am I going to do with that? Well, we have factors. 1 times 1 is 1, and write this as 7x times x plus 1 times x plus 1. You may also come across trinomials where you cannot factor out the leading term, like 3x squared plus 17x plus 10. For these, we can do something called the AC method. We're going to take the leading coefficient of the x squared, multiply it by our constant c, so 3 times 10 is 30. What we want to do is find factors of 30 that add up to 17. So I'm going to write 2 and 15. What you're doing here is you are going to split up the 17x as 2x plus 15x plus 10. We're keeping the value of the expression, we're just writing it in a different way. And we're going to do something called factoring by grouping. So you're going to take the first two terms together and the second two terms together. And you're just going to look for what they have in common. 3x squared and 2x have an x in common. I'm going to take the x out of 3x squared, it's 3x. I take the x out of 2x, it's just a 2. We're going to do that on the second piece as well. So 15x and 10, that has a 5 in common. 5 goes into 15x 3x times. 5 goes into 10 2 times. It's not a coincidence that this expression, 3x plus 2, is the same in both of them. So now we're going to take out the 3x plus 2, and we're going to look at what's left. Well, we have an x left, and we have a 5 left. So you're going to put this x with this plus 5. Now I've factored my trinomial. That usually takes a little bit of practice, so let's try it again. I have 6x squared minus 23x minus 4. I do a quick look and I see, well, 6 doesn't go into 23 or 4, so let's go ahead and multiply 6 times negative 4, which is negative 24. I'm looking at negative 24 and I want factors that give me negative 23. So what if I make that negative 24 and positive 1? Really important here that when I add these two together, I get that middle term of a negative 23. I'm going to write 6x squared minus 24x plus x minus 4. So think of these as your x terms. I grab the first two, I grab the second two. So I think about it. 6x squared and 24x, they have a 6x in common. That leaves me with x minus 4. Then when I look at x minus 4 as my second set that was grouped together, notice there's really nothing to take out. But this is what we're going to do. we're going to say I'm going to factor out a 1. The only thing they have in common is a 1. So there's always a factor. So when you look at it, you're like, I don't see anything. Then just think, let's throw a 1 out there. That makes this x minus 4 match this x minus 4. X minus 4 comes out. I get 6x plus 1. Let's talk about a few special cases. I'm going to start with the difference of squares. And what's really unique here is I don't have a trinomial. I only have 2 terms. I have a binomial. But this binomial is they're both square terms. When I factor that, I get x plus y and x minus y, and that's really helpful when you're studying algebra. So what I'm looking for here is 25x squared is like 5x squared. 49y squared is like 7y squared. So I'm going to have 5x minus 7y and 5x plus 7y. And you can write that either way. You could write the plus first and the minus later. It doesn't make any difference because you can always change the order of multiplication and it doesn't hurt anything. I want to make that a little bigger. Here I have x to the 6th minus y to the 8th. Now pay attention to these powers. It really looks like x cubed squared and y to the 4th squared. Remember, exponents, you multiply when you have a power to a power. So kind of think divide by 2. So I have x cubed minus y to the 4th, and I have x cubed plus y to the 4th. The next one, I have 5x squared minus 45y squared. And I want you to stop and look that 5 is not a perfect square, neither is 45. But what if I take that 5 out? Then I have x squared minus 9y squared, and that looks a lot better. Because 9, I'm thinking, well, 9 is 3 times 3. So I can leave that 5. And I can have x minus 3y, and then I can have x plus 3y. So you really want to watch for times that you can first factor something out before you try to apply any rules. It's important to say that there is not a formula for the sum of squares. Sum of squares cannot be factored. So if you were to happen to get something like that in the homework or a quiz, say you had x squared plus 9 and you're supposed to factor, the answer would be that this is prime. We cannot factor that. We can, though, factor the sum and difference of cubes. So let's look at both of those individually. Let's start with the difference of cubes. X cubed minus y cubed is x minus y. Then it's x squared plus xy plus y squared. The sum, x cubed plus y cubed, is x plus y, then x squared minus xy plus y squared. What I look at here, if I'm trying to memorize these, is I look for a pattern. And notice the minus is a minus. The plus is a plus. When I have this subtraction, the other two are positive. When I have addition, I look at it as a pattern of plus, minus, plus. So that's how I remember it. Everything else is kind of the same. They're both xy, they're both x squared, xy, and y squared. So if you can kind of establish a pattern for yourself, then it'll be easier to memorize. And when you're trying to memorize, the best way to do it, at least to me, is to write things down over and over and over. The more times you use it, the better you get at it. Until you have it memorized, though, I would say have a formula sheet. Write all these things down where you have a quick reference and you're not having to flip through all of your notes or go back to the book to find out what these rules are. So let's try this. I'm going to factor 64a cubed plus 125b cubed. Now, you might find it easier to say, well, the cube root of 64 is 4, and there's a cubed. 125, that's 5 cubes, I have 5b cubed. So remember, it starts with the plus, 4a plus 5b. Then it's just going to say 4a squared minus, you take 4a times 5b, and then plus 5b squared. So I used my formula of x plus y, x squared minus xy plus y squared. We have a little bit more to do. This is 4a plus 5b. 4a squared is 16a squared. 4a times 5b is 20ab. 5b squared is 25b squared. Let's try one with subtraction. So here I have 1000x cubed minus 1. 1000 is 10 cubed, so I have 10x cubed. And 1 is 1 cubed. So again, even if it's something simple sometimes, I can still look at it as a square, as a cube, as plus, as minus. So I really just go down to what does that stand for? So with subtraction, I start 10x minus 1. I always start with this minus this. Then I go to the squareds. So 10x is squared, then it's plus 10x times 1, and then it's plus again 1 squared. This is 10x minus 1. Then I have 10 squared is 100, x squared. 10x times 1 is still 10x, and then 1 squared is 1. It kind of looks weird because there's all these 10s and you feel like you can do more, but you really can't. That's why rules are important. They kind of help us focus and they help us tell when we are done. So for clarity, I want you to know that I kind of flew through this because I'm thinking this is a refresher for you, and that's all it's meant to be, as a refresher. If you need more, of course, reach out and ask for more. But this was just to kind of get ready for maybe solving some equations, looking for the roots of polynomials, but we just wanted to go back and talk about factoring so we're ready for it as we need it throughout the course.